Hello, everybody. I expect this will be my last video for artificial intelligence this semester. In the last video I did, I was talking about common sense knowledge, and I want to continue that and talk about an old program that's still going on. But it's a project that's been going on since 1984 that tries to bring common sense to a computer. The program is called CYC, which is part of encyclopedia. That's where they got the name. The program started in 1984 under the leadership of a computer scientist, Douglas the Gnat. He gave a lecture at the NIPS conference in 2008 describing his research with machine learning. His goal was to amplify human intelligence. He wrote several projects before working on Psych. He used the language Lisp, which was the language of artificial intelligence. One of the two of them, Prolog was the other, before everybody started using Python. One of his early programs was called AM, and it was an attempt to discover facts in the mathematical domain of set theory. I thought I'd show you a little snip of a Lisp program. This is a function in Lisp to do factorial. It defines a function, that's what defun is. The name of the function is factorial, and n is the input. And then if n equals 1, look at this, it would say, if n equals 1, return 1, else return n times the factorial of n minus 1. Now that looks easy. I mean, that way I said it is far easier than looking at this thing. The biggest attack on Lisp was the parentheses. Look at that last line. There are 5 parentheses there. It's so easy to get lost in the parentheses that you go almost insane trying to get your parentheses balanced in that language. But I thought you should see what preceded Python, shall we say. Now, I took a couple of slides from the lecture that Lynette gave. This is just one talking about his AM. He had 30 concepts, and they're listed there, 240 heuristics. And every task, he wanted the computer to explain it. So he wanted a justification, a priority, what you have to have before you do it, and the to-do list in that particular agenda. Now, in 1984, rather auspicious year, he started Psych. And here are a couple of slides about Psych. One of the things about Psych is its knowledge base. Unlike most of the programs we've seen, Psych was meant to take care of the entire world, essentially. And much of the stuff was put in by hand. So right now, there are 400,000 concepts in here. And this shows you many different domains that it has information on. Events that it can talk about are things like an object is placed somewhere. Someone is a beneficiary of something else. So it has these kinds of, you might think of them as functions, but they're not just binary functions. They have lots of possible inputs. They may have 2 or 3 inputs, 3 or 4, whatever. There are also relations between the agents and the propositions. So a person can hope that something happens. a person can expect that something happens. Uh, these bring in ideas that you're not exactly sure of what is there. Now, I have I'm pointing out a place that you can find some information on this. One of the things I like is that psych doesn't have to be consistent. Psych does not have to require that everything in its database be non-contradictory. Here are three things that might be in its native database. Nuclear power is dangerous. We should reduce the number of dangerous things. We need more nuclear power because of global warming. Well, those last two seem to be contradictory if nuclear power is dangerous. He also pointed out, Terry Winograd commented on this. He says there's a blindness of representation here. He's basically saying, and there's an example down here, you could learn, supposedly, the words in a made-up language. And you might be able to talk about them, but you'd have absolutely no idea what was going on, what they meant. And he had three answers here of whether or not the program that did this could understand. So the question really is coming up over and over. What does it mean for a program to really be artificially intelligent? At the very beginning of the semester, we talked about the Turing test. Well, now there's another test floating around called the WINograd schemas. Let me try to bring up some of this. Okay, there's some examples down here, if I can get to them. Here. The city councilman refused the demonstrators a permit because they feared violence. The computer's supposed to answer, who feared violence? Was it the city councilors or the demonstrators? Now, to change the word feared to advocate it, who advocated violence? This particular page talks mainly about the problems with pronouns. Who do they refer back to? There was a challenge for computers. Here's another page that shows some of these. What can the computer tell you about, it is morning and you recall that you have to take out the garbage tonight. You're afraid that tonight it will slip your mind. Now, the computer should be able to say to you, write a memo and put it where you can look it up if it had common sense. Why? How would you reason from that first sentence to telling the person to do the right thing? Now, I picked one of these for your very last homework, and it's not that hard, and you have over a week to do it, and we don't have a final, remember? Here is a very simple statement. Alice and Bob want to surprise their sister Carol with a joint present for her birthday, 2 weeks from now. They therefore go into a closed room to decide on the present and to plan how they will buy it. Now, how can the computer tell you that this won't work if you say to them, Carol was in the next room, but was also in the room? What common sense kinds of ideas would say that that surprise isn't going to work if Carol is in the room? Second idea, suppose the door's open and Carol's listening in the next room. Carol is in the next room. Why is it unlikely that the surprise will work then? So just write a little comments on each of these, uh, and it goes along with the last one that you did, the last common sense one. So that will be it. It's sort of a nice bracketing that we begin with the Turing test, and you've thought about that, and you've written on that, and you know that lots of people are feeling bad that that isn't really what we should have. And we're ending with this newer test, which basically is trying to say, to really understand the computer has to have common sense. And are we there? Probably not. And the Psych is a program that attempts to use what some people would call plain old artificial intelligence. It attempts to put information into the program and have the program use that information. The newer attempts are the machine learning and deep learning kinds of programs, which simply say we'll put some facts together and we'll tell the computer what conclusion we want, and it has to decide how to relate the facts. That it may use it any way it wants, and we don't even care about what weights it gives to various things. So that is it for now. Finish up what you're doing. We're almost at the end. Most of you are doing very well, so I don't think there'll be much trouble for the semester. See you all later now. Bye.